Okay, so now let us take a look at this question. So this question, it says that two forces F1 and then F2 are of the magnitude 19 newtons and then 21 newtons respectively. If the magnitude of the resultant force is 37 newtons, calculate correct to the nearest degree the angle between F1 and then F2. So now with this question over here, they have given us the resultant force, that is the magnitude of the resultant force. We have the magnitude of the first force and the magnitude of the second force over here too. So with this, we can draw a diagram. So the first force, that is the force 1, is equal to 19 newtons. The force 2 is equal to 21 newtons. The resultant force has been given to us, that is the 37 newtons. Now we are to find for the angle between the two forces. So this, the angle between the two forces. Now, if we represent the angle between the two forces as theta, then this over here is going to be theta, 180 minus theta. Okay, so again we are going to use this over here to do it. So I have the resultant force squared is equal to force 1 squared plus force 2 squared minus 2 times force 1 times force 2 times the cos of 180 minus theta. Now there's a way you can rewrite this over here to have it as just cos theta, and then you change the sign over here to addition. But I am not going to use that method. I will not use that. Okay, what I'm going to do over here is I'm going to represent this over here with another variable, so maybe alpha. So I will let alpha be equal to 180 minus theta. Okay, then now I can rewrite what I have up here as, so the resultant force squared is equal to force 1 squared plus force 2 squared minus 2 times force 1 times force 2 times the cos of alpha, where the alpha is what we have over here, that is 180 minus theta. So from here, our goal is to solve for the alpha. Now 19 squared is equal to 361, 21 squared is equal to 441. Then I multiply this to get 798. Now I put this together, so I add this to, when I take it to the other side to subtract from this, I'm going to get 567. That is equal to, now this is negative 798 cos alpha. Now I divide through to get, so cos alpha is equal to 567 divided by 798. So now when I punch this on the calculator, I get the decimal to be negative 0.7105. Now when I take the cos inverse, so I take the cos inverse of this, so the cos inverse of this is going to give me 135.3. So from after getting this over here, you're supposed to do, I think that's not broken, so but then we're supposed to show it. So the cos, you're supposed to do the cos inverse of, so negative 0.7105. And when you punch this on the calculator, you're going to end up with, so 335.3. That is going to be our alpha. But then the goal is not to find for alpha, the goal is to find for theta. So now we are going to make back our substitution. So theta is equal to 180 minus alpha. So 180 minus the 135.3, that is going to give me 44.7. But then we are to have our answer to the nearest degree. So therefore, the theta is equal to 45 degree. And that is our final answer. That is how to solve these questions. So with this, we are given the magnitude of the three forces over there, and we are asked to find the angle between the force 1 and the force 2. We still use the same formula over here for that.